so why don't we just kind of wrap up? So we're on to conversations about science now. And so where we left off is with the Cambrian explosion, which is one of the major challenges to evolution, particularly macroevolution. And so what macroevolution is, which is what we discussed past couple weeks, is the idea that certain species can essentially evolve into new species, novel species entirely, right? Because there's another type of evolution which is completely non-controversial, which is microevolution, which is the idea that you can have variation within a species, right? So we were kind of talking about dog breeds, right? And how you can have, a particular dog breed that if you breed it in a certain way, you kind of create an entirely new type of dog, but it's still a dog, right? It's not turning into a cat. Which is what macroevolution proposes, is that you can actually have a dog becoming a cat or something like that. So what the Cambrian explosion is one of the biggest challenges to that, because evolutionary theory hinges upon lots and lots of time, right? So in order for these genetic mutations to happen, they're not happening by any kind of design, right? Because that's what intelligent design would say. It's happening by chance. And for chance mutations to happen, you need lots of time for them to kind of accumulate and turn into an entirely new species. And not a short amount of time. You need lots of millions of years, right? And so in terms of geological time, 20 to 40 million years is not that much time, right? Which to us sounds kind of mind-blowing. That's a very long time to us. But as far as the amount of time that you would need to get that kind of cumulative effect with those mutations, it's just not enough time. And over this time period, you go from so in the Precambrian era, which is about 570 million years ago, it's something I should probably say, I kind of established in the last class. This presumes that we're talking about an old Earth, obviously. If I'm talking 570 million years ago, this is presuming that we're not talking about a 10,000-year-old Earth, which is what a young Earth creationist would say. But we're just going to kind of, presume that the old Earth is we're just going to hand that to the evolutionists for a second, that it actually is an old Earth, just for argument's sake, right? So if you believe in a young Earth, we kind of covered that in the last class. We're just kind of presuming that for the discussion of this class. So scientists say that 570 million years ago is when the Cambrian explosion happened. Before the Cambrian explosion, very simple life, right? Like single-celled organisms, maybe a couple cells would be the entire life form. But you go from that to then the Cambrian explosion, you have vertebrates, so an entirely fully formed fish and other types of sea creatures that have spines and organs, their heart and lungs and all that. So you can imagine going from a single cell to lungs, heart, spine, all that. It's the amount of mutations that you'd have to get in order to kind of explode into that kind of life form is just astronomical. You get insects and crustaceans, and then you also get jellyfish and those kinds. So you get all of your major body plans over that relatively short period of time. This is kind of I'm just kind of reiterating this from last week. And so, without getting too much into the weeds, it's just too much happening in too little time for it to be plausible, right? And that's really the main thing, or the main takeaway with the Cambrian explosion. If you want to know more about it, I have the video from last week, up, so we can talk about that, or you can just refer to that. But any questions on the Cambrian explosion, or kind of like why it is such a challenge for evolutionary theory? Okay. So limited junk DNA. So I'm just going to backtrack a little bit with this too. So anyone remember what junk DNA is? I kind of briefly discussed it last week, so I guess that'd be Caroline and Ryan. Do you guys remember what that might refer to?
Was that the one we were talking about, like really oddball mutations?
Right, it's connected to that. That's yeah. So in order for that to happen, right? He's talking about what's called an atavism. Which is the idea that you'll have this sporadic reemergence of a trait that was long lost. So you're probably familiar with the idea that we came from apes, right? So man evolved from monkeys, and so there's. I can probably just go back to the slide. Hang on, where is it? So this is the atavism. So this boy apparently was born with with black hair all over his chest, and they would say this is like a reemergence of black hair that we used to have when we were apes, right? And so, but what that's presuming is that we have that still in our DNA. That our DNA still has that gene that would, if activated, allow us to have hair all over our bodies, right? So that's what they're saying. It's kind of assuming that there's this junk DNA that we're no longer using, but through accident of some kind or just some sort of abnormality, it just gets fired up again, and you end up with that kind of trait. So that's what an atavism is, and it presumes that we have all of this junk DNA in our DNA sequence. And so it's non-functional DNA that accumulates in the genome. And so in 2003, the mapping of the DNA indicated that only 2% of DNA was functional, right? Which lines up with their theory, right? So if we were to have, say if our DNA strand goes all the way back to the time that we were an amoeba, right? That we were just a single cell, you'd imagine how much DNA would have to be added for us to get to be a human, right? Because think of how simple a single-celled organism is. It's just not going to be the same type of sequence as it would be for us, right? But over time, if we're going to have all these mutations, compounding and compounding and compounding, there's going to be this long strand of DNA that's just not being used, right? And so the idea that only 2% of the DNA was functional seemed to line up with their theory because, well, there's 98% of the DNA that's not being used. Okay, and actually this is where I left off. So I think I've told some of you before that I went to a very, very liberal high school. And that was what was told me in 2005 or 6 when I was taking that class in biology. And that's where it was left. I'm like, oh, that's pretty bad. That doesn't sound great. But then, after I was out of college in 2012, there was a research study that demonstrated that 80% of the DNA was functional. So, whoops, right. Well, it's just constantly in flux, yeah. So, what's that?
That's out of the margin of error. Like, I could have seen it if you were being told, like, 60%. They're like, well, okay, it's 80.
Yeah.
But you should, like, that's like somebody who wasn't looking at it.
They were awake for the last 2%. So, yeah, I know, it's ridiculous.
It's like, here's what we want you to find. Oh, yeah, here's what I found. I want to.
Yeah, I know. And so much of it does seem to be that way, like they have this idea of what they're looking for, because a lot of this evolutionary theory comes out of, it presupposes naturalism. There is no such thing as a supernatural realm, and so it's always through that lens, right? The second that you introduce, a supernatural element, they're like, nope, that can't be, because there only is the material universe. Now, whether or not that's what was going on in this case, I mean, it's pretty much, well, they're always looking through that lens. But there was a somewhat of a reason for this error, which is because, I know, Ryan's like looking at me like, what could that be? That's right. Right. So the thing is, in 2003, when they mapped it, what that 2% is are expressed genes. So those genes that are immediately responsible for the features of our body. So hair color, eye color, height, weight, all those kinds of things. Even like arrangement of organs, like all that stuff, right? Now, that rest of that, 78%? Are coordinating genes. So they're actually deciding which ones are being expressed. They're not the ones that are immediately responsible for it. They're the ones that are telling it what to do, right? So it wasn't as apparently, and now I'm putting it in layman's terms, right? Because I'm not a scientist, I'm not a biologist, but this is my understanding of how it was put in the book, is that it's basically like, air traffic control, right? So where you have like people in the tower that are saying, okay, this flight can land, this one can take off. But you can think of like in this analogy that the initial 2% were like the pilots, right? They're the ones that are actually driving the plane, and then you have air traffic control, and most of it is air traffic control. That's 78%. Now that's up to 2012, and it said that like there's still 20% that's apparently still non-functional. We might still find out that it is functional. We just don't know yet. In fact, just with that big difference of 78%, I'm like thinking, well, we're probably eventually going to figure out what that other 20% is doing. We just don't know yet. Right.
How long have you been like actually studying DNA? And when did we first map the genome? They say
2003.
That was the first time.
First time. Yeah, it was in process for a long time. I think like into the 90s. I think was when that whole process had started. But I think they completed it in 2003.
So like at that point, this was all brand new. So everybody's like, hey, let's take a look at this.
Right.
And nobody knows anything about it at that point.
Right.
Well, this one is obvious that it controls your eye color. This one's obvious it controls your hair color.
Right.
So, yeah, it seems like as we would get into more and more and be like, okay, well, now these are the ones that control when things happen, and these other 20% are actually the ones that are way behind the scenes.
Right. You think of how many dimensions that could be involved in that whole process. I mean, that's what I see when I look at that, because they still say that 20% is non-functional. I'm like, how do we know that? So yeah, it seems a little bit absurd to say that. But let's just say it was non-functional. Let's just say, okay, for the sake of argument, it is non-functional. If we're talking about evolving from a single-celled organism to now, far more than 20% of our DNA sequence is going to be junk, right? I mean, because think about how many mutations have to happen. In fact, I would argue that 2% is still too much function, right? You think about, like, I mean, it would be a fraction of a fraction of a fraction of a percent. You know, I mean, because we were reptiles at one time, we were fish at one time, we were all sorts of variations of mammals. I mean, think of how many mutations have to happen in order to get to a human being from a single-celled organism. I mean, it's like infinitesimal. That would, you know, what percentage would actually still be functional today? And so, but to try to account for that with 20%, it doesn't make any sense. So it really does defy evolutionary theory predictions. Any questions on that, or just because some of this stuff can get kind of heady, so I guess we kind of like hammered that one pretty hard, so we can probably keep going. Yeah, okay. So harmful and neutral nature of most mutations, okay? And I've got a picture of the X-Men up there, because the X-Men. So let me just ask you guys: when you think of mutation, what do you think of? Or mutant? How about that's right. That's what I think of when I think of mutants. That's right.
I think when you say mutations, I think of like people that have diseases and stuff. They say it's a mutation.
Yes.
Of a gene.
Right.
When you say mutants,
Yeah, with that picture up there, that might influence you to think some other things. Right. But Ryan, do you have anything else, or?
That's kind of what I was going to say. Usually, if you think of in the real world, a mutation, it's something out of the ordinary that is. I don't think I've ever heard of one that was beneficial.
Right.
It's always been a detriment or an oddity.
Right.
Like it's something that shouldn't be.
Right.
It shouldn't be there in the normal plan of the human body, the way it functions.
And when it does happen, it's a bad thing usually.
Yeah. It can be benign.
Yes.
Or it could be detrimental.
Right.
It's never like, I don't know, hey, now I can see in the infrared.
Right.
I can also see color, but now I can see the body heat of the people in the other room, and like, it doesn't go up. It always goes back.
Right. That's
And if you can show me a person in real life,
right.
that it did go up and was beneficial, I'd be a little skeptical.
That's right, and it's apparently they have, and the book didn't really go into it. And my guess is when they're saying that there have been cases of beneficial mutations, maybe it gave them like a height advantage of some kind, or maybe they became stronger, but never like that supernatural type of like mutation where literally like the X-Men, where you have like you can shoot laser beams out of your eyes type thing, right? So that like has never happened, obviously. But apparently there have been, but like very rare. Like so when Ryan's saying that most of them are either they delete information and they cause a problem, or it's just a neutral mutation where it might be a quick flip in some of the DNA sequencing. It's usually harmful or neutral. And the thing is evolutionary theory relies upon mutation. So mutation is what makes it possible to get to the diversity of life that we have today, because that's how they get new information, right? If you don't have mutation, then there's no way to really add in information in order to create something like a new species, right? And so it really, that theory hinges upon the reality of beneficial mutations, and beneficial mutations in like large numbers, right? And so it's happening pretty frequently because, again, so if we go back to the Cambrian explosion, we're going from a single-celled organism to a full-blown fish over a course of like 20 to 40 million years. And I know that sounds like a lot of time to us, but really, geologically speaking, it is not much time at all. You'd need beneficial mutation after beneficial mutation after and all happening at once. Right, so it's just really unlikely. It defies all kinds of probability for that to actually happen. And we just generally don't see that happening. So I think I said this at the beginning of our conversations about science. There was a guy, Dr. Richard Lenski, who's literally been keeping cultures of E. coli bacteria since like the 1980s, and just kind of allowing them to regenerate, just to observe, like, well, is there ever a beneficial mutation? Has it ever turned into a new species? And at the writing of this book, 60,000 generations had passed. Okay, that's a lot of generations, and it's still E. coli bacteria. I guess there have been some cases of it kind of, that's what it is. Beneficial mutations. Sometimes, like certain bacteria will be resistant, so they'll become resistant to a certain type of antibiotic, and so that's the instance. So that's the only instance I think that they have of true beneficial mutations happening, but that's really it. But it stays as E. coli, and generally they're all bad mutations when they do happen. And so some examples of the types of mutations that we typically see, that Ryan may have been referring to, cystic fibrosis, so that's one of them, right? So that kind of, you get mucus in your lungs and your digestive tract, it affects your ability to breathe and to digest properly, so obviously that's a bad mutation. Sickle cell anemia, so it changes the cell shape of your red blood cells so that you don't absorb oxygen the same way that you used to, and you become very fatigued and tired, so obviously it's not helping your function. Color blindness is another one, where obviously it's not helping your function either. Now, did I want to say anything about that? Yeah, I think we're good. Any questions on harmful or neutral nature of most mutations? Yeah, so that's just kind of a general truth. They really don't have much evidence that the kinds of beneficial mutations needed to have something like evolutionary theory be true is an actual physical reality. So then we have changes from natural selection. This isn't really much of a slide. This is just kind of showing that there's some fracturing going on within the scientific community concerning evolution and natural selection's ability to account for all of the evolutionary problems that we have. So this is kind of, the third way of evolution is kind of this new group within the scientific community that's trying to maybe push back a little bit on more traditional type of Darwinism, which really uses natural selection as its main basis to explain the origin of life, how life came to be in its current form. So this is kind of what they said. They said, some neo-Darwinists have elevated natural selection into a force that solves all the difficult evolutionary problems without an empirical basis. And so just as an example of that, last week and the week before we were talking about transitional fossils. So Aubrey and Brent, I don't know if I don't think you probably heard about that, unless you watched the video, but transitional fossils so let's just kind of take it back. So if we have a single-celled organism turning into all the different forms of life that we have today, you need all this forking, right, going off. So we have this one becoming a fish, we have this one becoming a reptile, we have this one becoming a mammal, and you need all this kind of it looks like a tree, right? And so in order to get that, you would need to have all these transitional organisms that would go from a single cell to a jellyfish, right? So they would and it would have to have like certain hallmarks of a jellyfish, but also certain hallmarks of a single cell organism, which they have no evidence of any of that, of those kinds of fundamental transitional fossils. And what I mean by that is they have ones that they might think went from, say, a bird to a reptile or something like that. But again, these are vertebrates, so it's staying within the vertebrate class. They don't have any examples of a single-celled organ or a jellyfish turning into a vertebrate or something like that. And even that, it's not empirical. So they can look at the fossil record and show that, well, we have something that kind of looks like a bird, but it also kind of looks like a reptile, so this is probably an in-between between the two. Right, so, and you're laughing because, that doesn't necessarily say that at all. It just could be a completely new organism that it's not transitioning, it's just a bird reptile of some kind, right? And so they're creating the story out of the, what's in the fossil record. It's not necessarily empirically true. It could be, but there's no objective way to show that it actually is. And so the third way of evolution is kind of saying that, some have elevated natural selection into a force that solves evolutionary problems with no empirical basis. So there's really no empirical basis for some of the conclusions that they're drawing. It's not scientific, in other words. Any questions on that or comments?
What would they say is, and you know what I mean?
Right.
They're if they're saying something else is driving these changes, what would those scientists say it is?
Right. So one of them so there's the theory of punctuated equilibrium. That's one of them. So, because remember how I was saying that, just these changes happen too rapidly, right? And with the Cambrian explosion anyway. And there's just no examples of transitional fossils. So they have this idea that somehow you have new beings coming into existence very quickly because of certain environmental pressures. So there was some change that happened on the Earth during a certain period of time, and it caused rapid evolution, like so quick that the fossil record didn't even keep record of it. But I know that sounds even more far-fetched, and it is more far-fetched. And so that's kind of what they do. They kind of go into these other realms, which honestly cause more problems than solutions. As far as the third way of evolution goes, I don't know exactly what they're proposing, and in fact, I'm not sure that they actually have a proposition. I think that they're just saying, we don't really, natural selection isn't really enough. It has its own problems, and I think they're interested in looking to alternatives, but they're also not interested in looking into intelligent design either, because they hold a naturalistic worldview. They don't actually think that intelligent design or God is a real being, and so they're going to kind of automatically dismiss that, but they think that there's another material explanation. They just don't know what that is. So, yeah. You look confused, Ryan.
No, I'm just trying to think. I feel like once you get into that, you get into aliens, like I said the other week.
Did you say aliens?
Yeah,
Yes.
Aliens came here and put these creatures on the Earth, and then they kind of helped it along, and it really goes sci-fi.
I know, and yeah, right. It's the lengths that they will go to deny God, right? God to them sounds like aliens, and so they actually think aliens are more plausible than God, which is why they're willing to go that direction. Which is why I think it's so important for us to know in the beginning of the class, our evidence is for God, right? Because there actually are very good reasons to believe that God exists. And I think if we can effectively communicate to some of these people, some of them are not going to listen to you no matter what, right? But some of them might be like, oh, I didn't know that you could logically, deduce that God most likely exists, which is why I think that's kind of helpful. But there's something I was going to say, and I've lost my train of thought. But any other questions, comments on that?
I just don't get how they can, even if you say the world was full of single cells.
Right.
But where did they come from?
We're going to get to that. Yes.
If mutated 9 million thousand times, but
Right.
From
From what? I know, and that's a very good, I love that you noted that, because we're going to come up to that in, actually, right now. So challenges from origin of life. So evolutionary theory primarily explains how life changed after it began, right? So Aubrey noted that, so they have all these theories about how it kind of went from being a single cell to, a couple cells to a whole human, but where did that first cell come from, right? Where did that first life come from? And it doesn't do that. Evolutionary theory does not account for that. It doesn't tell us how life began at all. So it also needs to explain how life began. Evolutionary theory proposes that life first emerged from non-living matter, which is, in their theory, it's called abiogenesis. So the way that they get that name, a meaning not, I believe this is in the Greek, or maybe Latin, bio, life, so not life, genesis meaning to be created. So it was not created through life. And that's essentially the only conclusion that they can come to. If there was no life to begin with, well, it must have come from not life, right? And so they'll say that it came from, inert matter, basically, water, rocks, something like that. And they have their theories as to how that could be possible. They have no evidence that actually happened. It's never been observed. Spontaneous generation has never happened so far as we know. But this is really a huge challenge to the naturalistic worldview. And so for people that are being challenged, by people saying, well, evolutionary theory is obviously a fact, the two big things that I say to memorize, just remember in your head, Cambrian explosion, how does all of that happen so quickly? It really, by their own theory, it's too fast. So it doesn't work for them. So they have to come up with ridiculous theories like punctuated equilibrium. And then also ask, like Aubrey said, how did it start at all? Abiogenesis is a contradiction? Like, how does that, you can't get something out of nothing. So, it really is, those are the two of I think the best challenges to evolutionary theory if you were to ever find yourself in a discussion, or if your children end up in a conversation with some kid from school and they start to challenge, creationism or such. So if I had to pick the two that were most important to keep in the back of your head, those are the two I would say. And then this too. So we also want to give a positive case. Okay, so we've kind of taken the case of evolution, right? All the evidence that they give, and we've kind of torn it apart and shown, well, you kind of got some big holes in there. But we also want to give a positive case for creation, right? And that's what intelligent design is, right? So we're not only saying that your theory is bunk, we're also saying that our theory is good, right? That there's actually good reasons to believe that there is a creator, that there is an intelligent agent behind what we see in the universe. And that's what intelligent design seeks to do. So it's the theory that features of the universe can be explained by an intelligent cause. Now, what's important to note about intelligent design as a discipline is that it's not necessarily it's not making any religious commitments. So it's not saying that it's the God of the Bible, it's not saying that it's Allah, it's not saying that it's Krishna, it's just saying that there's an intelligent agent behind the creation of the universe. And so it's really kind of taking, really just trying to blow that evolutionary idea out of the water. What else? Let's see. Scientists say that biology has the appearance design, but they reject that it is designed. And this comes from what I was saying earlier, how they presuppose a naturalistic worldview, which I think when you point that out to some people that are, in the scientific community, or that maybe just really their whole worldview comes from the idea that, we can only know what science proves. Well, that in itself is a belief, right? That only science, that's not science telling them that. That's just their belief that science, is the only way to know truth. And so they're assuming a belief system when they negate anything that could be supernatural. So and that could really lead to some bad conclusions, because what if God did create it? Well, you're never going to find that if you never have that on the table, right? So does that make sense? Am I following? Sort of. Okay, so scientists say that biology has the appearance of design, but they reject that it is designed because they don't believe that there is anything outside of the material universe. Anything else I want to say on that? Yeah, so the question is that, is there an objective way to determine if something is caused by an intelligent agent or not? Can you guys think of anything? Like if you wanted to deduce whether something was happened by a person as opposed to just the wind blowing, how would you do that? You don't have to. I don't know that I would have been able to answer that either. I was just wondering if any of you had any ideas.
I was just going to say, you can observe what it is,
Mm-hmm.
what it's made of,
Mm-hmm.
and observe how things are going. Like if you look at a clock.
Right.
Okay, so it's made of little parts, and it's ticking around, Or if you look at a rock that's being shaped by the wind, like how long does that take? Well, okay, you got to watch it for a long time.
Right.
Like just seeing.
Yes, you're right. Observation is really kind of how we can do that, which is what science is doing, right? And that's how we can know that this is something testable. If we can actually observe, certain features, it's just what features though are we looking for? And this is where I would have had trouble, I don't know if I would be able to answer that. But this is kind of this kind of paints the picture. So does anyone assume that Mount Rushmore was created by erosion? Right? So if you had some native of Brazil that had never been exposed to any kind of, Western life, and you just plopped them right in South Dakota and they saw the, Mount Rushmore, what are they going to assume? Who did that? Could have been a couple things. It could have been, maybe it was God. God might have done that, or whatever concept of God is, right? Or it could have been a human, right? But they're not going to assume that erosion did it with rain. Okay, that's not going to be the conclusion that they're going to draw. But why, right? And that's the interesting part. So what objectively can you look at that kind of makes the difference between something that was created by an intelligent source as opposed to not? And so detecting design in biology. And please, whenever I ask questions or I seem like I know everything, I'm basically Alec Trebek, okay? I just have the answers in front of me. So I'm not trying to make you guys feel silly, because I would probably not be able to answer these questions either if I was in your seat. So design can be detected when specified complexity is exhibited. Wow, that's a big word. What is specified complexity? That's like answering a question with another question. Okay, so it must be contingent, complex, and specified. So we're going to spend the remainder of the class, we'll probably just wrap up right at the end there. So let's talk about what contingency is. So contingent means that something is subject to chance. Okay, so it's not something that happened out of necessity. And the reason I have a snowflake up there is because if you look at a snowflake, doesn't it kind of look designed? Like someone kind of arranged that, and it's like looks like it kind of has a certain pattern to it. It's pretty complex. But the thing is, what separates a snowflake from something that might actually be designed by a human or an intelligent source is that it's forced to take this shape. The properties of water, natural law forces it to do this. And that's what we're kind of parsing out when we're saying if something is contingent or not contingent. Things that are forced to do something, like a ball is forced to go to the ground because of gravity. Ball going to the ground is not contingent, right? Because it's not subject to chance. It has to go to the ground because of gravity. In the same way, a snowflake has to take its shape because of the properties of water, right? So yeah, that one would not be contingent. Did not occur as a result of a necessary event or condition, and right, I think I covered that. Okay, any questions on contingency? Good, cool. Complex, okay, so what does it mean to be complex? So it refers to improbability, and actually I can probably just pull them all up. So the more complex something is, the less probable it is to occur, and it prevents scientists from attributing every improbable event to design. So the way that I think it's just easiest to grasp this is, let's just say, okay, our 1.5-year-old is scribbling on a piece of paper, right? And you just happen to notice that they happen to scribble 2 vertical lines, 1 horizontal line, and another vertical line right next to it. It looks like it's saying hi. Is it saying hi? No, probably not, right? It's too simple, right? It's not complex enough. You need it to be more complex in order for it to be considered to be designed, right? And so, even though, yes, your daughter has the capacity to be an intelligent agent, and she is intelligent, she can do certain things, but not intelligent enough to write hi yet, right? That's not something that she has the capacity for at that point in time. And so, now, if she wrote, "Hi, Daddy, my name is Susie. I want to go play with Lara later. Can you give me some cookies?" Design, right? So, yeah, that she is an intelligent agent at that point. You are not assuming that. Because it is complex, right? There's a lot of letters that go involved into making that message. And it also has a pattern, because language has a pattern. Because the way that certain letters are arranged, the spacing of them, right? They create words. That's all pattern, okay? And so, yeah, so the more complex something is, the less probable it is to occur. Now, I already incorporated the last one a little bit, which is specified, which is patterning, right? So, and I'm just to kind of like show you how complexity is different than specification, I'm going to kind of give you another example. So, specified is the information matches a known pattern. And we're going to use coin flipping to kind of paint this picture. So, sometimes very complex things happen, but they are not designed. Okay, so when you're flipping a coin, right, 3,000 times, and you're getting a sequence, heads, tails, tails, heads, 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 tails, heads, tails, heads, tails, 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 heads, right? Is that designed? No. Is it complex? And that just might mean, like, I might need to define complexity. So complexity just refers to how improbable it is to occur. So if you flipped a coin 3,000 times and you got a certain sequence, what's the chances that's going to happen again with that exact same sequence? Almost nothing, right? But that's all chance. It's just, in order for it to do that second part of you getting the exact same sequence, that would have to be a pattern. But you just flipping randomly is not a pattern. Now, if it were to go heads, tails, heads, tails, heads, tails, heads, tails for 3,000 times in a row, does that have a pattern? That indicates design, right? So, but just random, coin flips, it creates an extremely complex sequence, but it doesn't have pattern yet, right? And pattern is what we're referring to when we're referring to specification. Does that make sense, or any confusion on that still? Okay. If something is ever confusing, just stop me. I'm happy to stop. But yeah. So the thing is, once things have all 3 of them, right? If they're not contingent, meaning they're not forced to happen, they are subject to chance. They create a complex pattern, and they also demonstrate some sort of specification that they have a pattern of some kind. There are no cases of that happening without it having an intelligent source. Look at nature or anything, this table or whatever. They all have an intelligent source, whether it's a human or, well, potentially God, which is what we're looking at. So specified complexity in DNA, right? So, anyone, a materialist will say that, well, sure, specified complexity is true. It's just you can't apply it to biology because there is no intelligent source behind that, right? Because they're assuming that there could not be an intelligent source behind that. But what if we could show that there is, specified complexity in something like DNA, right? Humans didn't create DNA. We would say that God created DNA. They don't have an intelligent source that created DNA. But what if we could show that it had specified complexity? Okay, so let's look at DNA a little bit. So DNA has now some of you might not have been here for this class, but DNA is made up of 4 chemical bases, right? So thymine, guanine, cytosine, and adenine, right? And there are 3 billion variations of those chemical bases, right, that make up our DNA sequence. 3 billion. Okay, that's a lot more complex than a coin flip, 3,000 times even, right? So we have 3 billion of those. They are expressing a pattern, right, because they express information, right? There are certain consequences that happen from that arrangement. They send messages. Message creating my eye color. Message creating my, hair. Whatever. There's message create my everything, my skin color, everything. So it has a pattern of some kind that's being used to derive relevant information. Contingency. Can we predict a DNA sequence? Can we predict, during reproduction that it will be arranged in a certain way? Or is it kind of subject to chance?
Yes, I guess because it's a child's DNA is coming from the parents.
Right.
They've been able to draw a line to that, so I'm guessing that they can predict it to a certain extent.
Well, the exact code that comes up. So yeah, you see what I'm saying? So like the how it actually gets arranged, it's coming from both parents, but could they actually predict what, I guess what codes are going to be made up out of that, combining of them? To my knowledge, no.
I was going to say, I'm not sure.
Yeah, I know. We're not.
They've sequenced. I mean, people go to.
Oh yeah.
They go to school for genetics and they know sequences. So I wasn't sure.
Oh, they'll look
to
at.
what extent that they've been able to.
Yeah, so they'll look at already made sequence. They can look at yours and my DNA and code it. But can they predict prior to essentially 2 parents coming together what that sequence will be? No. It is subject to chance. There's no way to know. And so you have specified complexity, you have contingency, and you also have specification. And so you have a case of of specified complexity in nature, which is a strong inference that they came from a designer. And so this is kind of like DNA is actually one of those really cool examples of something that there is no evidence of something that has specified complexity ever occurring without an intelligent source. And so it's kind of a nice way to make a positive case for intelligent design real quickly, because if you're talking to an evolutionist and they're saying, well, intelligent design is just like a bunch of baloney. Well, you say, well, how do you explain that DNA has it? It's just kind of like nice things to keep in your back pocket if you were to ever end up in that kind of discussion. Any questions on that or comments? It's a fascinating field to look into, intelligent design. It can get really complicated. I'm kind of reading a book now on it because I'm hoping to do a more in-depth class on it in the future, just to kind of hash out some of it. But it gets really technical at times, and some of it's above my head. But I try. But it's interesting. It's very interesting to look into. So that's, yeah, you hit that.